This video is on exponential decay. We're going to do a real-world example. You buy a computer that costs $1,200. It depreciates in value every year by 10%. So let's break this down. The first thing we see is that it costs $1,200. This is how much you paid for it to begin with. So this is the initial amount that you started with. It depreciates, that means it goes down in value. So we're going to deal with decay every year by 10%. Now, that percent, because it's a percentage, means that we have the rate. This does not tell you your factor. 10% is a rate. We need to find our decay factor based off of our rate that we have decreased by. So we want to write a rule showing how much the computer is worth C after X amount of years. So it is going by years. So we need to know our decay factor, knowing our decay rate. We have a decay rate is 10%. So the rate is 10%. From 100% going down 10% would give us 90% because we are decaying by 10%. From 100, that gives us 90% of the original value. That tells us that our decay factor, the number we want to use, is 0 and 9 tenths or 90 hundredths because we change the percent to a decimal, so we change it into a factor. This is the number we actually want to use. We are decreasing by 10% from 100%. You have to have the decay factor to write your equation. So our equation would be y equals a times b to the x. This is C is equal to our A, so our starting value, 1,200, times our decay factor is a 0 and 9 tenths raised to the exponent of x. That's the difference between knowing if you're given the rate or if you're given the factor. We need the factor to be able to write the equation, not the rate. So now we can write the now next rule that represents the same situation. To get the next value of our table, we will take what we have now and we would multiply it by 9 tenths. But we start at $1,200. So if we want to complete the table to show what it's worth for the 6 years you own it, so we only own it for 6 years, we want to use this next equals now to be able to fill out the table. So the first value that it cost was $1,200 because that's how much we had to pay for it. Now, how much is it worth after that? It depreciates in value, so if I wanted to sell it, I can't sell it for the $1,200. So I will multiply by 9 tenths to get to my next value. So 1,200, so now times 9 tenths gives me the next value. If I multiply this by 9 tenths, I would get $1,080. If I multiply this value by 9 tenths, I get $972. I'll then multiply 972 times 9 tenths, and I will get rounded to the nearest hundredth because it is money. I would get $874.80. I'll then multiply that by 9 tenths. I'll get $787.32. Again, rounding to the nearest hundredth because it's money. We'll multiply that by 9 tenths. We'll get $708.59. Multiply by 9 tenths again. We'll get $637.73. So after 6 years, I could sell it for about $637 to be able to see how much it costs because it's depreciating each year. So what will the computer be worth in 10 years? Well, I have 6 years already. Now I could keep going, or I could use my equation And I could find out what the 10 is by plugging in the 10. So let's do that. The equation C equals $1,200 times 9/10 raised to the x's years. I want to know what it is in 10 years, so I would raise it to the 10th power because x is equal to 10. So when I plug that in, when I get my values, I'll get $418.41 because again, we're rounding to the nearest hundredth for money. And I do want to use my units. Money is in the front. So when will the computer be less than $300? This is when I could actually continue with my table to see what happens with my table. So looking at the table, I would keep multiplying by 9/10, and I know that at 10 years, it's still above 300. So I know it's going to be after 10 years. So if I continue with my table, we'll see that at 13 years, it is worth roughly $305.02. So any time after 13 years, it will be worth under $300. So if I write that out, I know at 13, it's not under $300. But anything more than 13 years, it'll work. So that's why I'm not putting the equal to sign on here, because at 13, it's still $305. But anything after 13 years, I know that it will be underneath $300. So that's why we put x is greater than 13. Now, if we were to use Desmos, we could put y is equal to $300 and y is equal to 1,200 times 9/10 raised to the x and see where they cross. And we could get the actual exact time of when it'll cost $300. So then I could say this very specific value of when it will be less than $300.